This will be the first video in a series regarding heat, thermal energy, and enthalpy of reactions. So what we're going to be looking at is energy involved in warming or cooling a substance, how to measure that, the temperature changes that go along with it, and then also the enthalpy or the heat of a reaction. But in this first video, we need to become familiar with the temperature scales. Okay, we are often familiar with degrees Fahrenheit. We're often familiar with degrees Celsius, what we would commonly call the metric scale of temperature. And then there's also one in chemistry that we use that is most commonly used in chemistry is the Kelvin scale. And it's just symbolized with a capital K for Kelvin. Okay, so in this video, I'm just going to show you the formulas used to convert from one scale to another. Okay, and we're going to focus on Fahrenheit, Celsius, and Kelvin. So when we go with Fahrenheit scale, okay, the degrees Fahrenheit is equal to, now a lot of textbooks will use 9/5. 9/5 degrees Celsius, those two multiplied together, plus 32, okay, as the conversion equation. Personally, I like to take this and get rid of the 9/5 and just call it 1.8. It's easier often to put into a calculator and to work with. We can avoid fractions. Okay, so I normally use 1.8 degrees Celsius, plus the 32 is equal to the Fahrenheit. Okay, so here's an example. Let's say we've got 28 degrees Celsius and we want to know what that is in Fahrenheit. So we go Fahrenheit is equal to 1.8 times 28 plus 32. Now, there are a lot of conversion calculators out there on the internet and so forth you can use, but your instructor may not always allow you to use the internet, so you need to know the formulas. So 50.4 plus 32 here, so we get 82.4 degrees Fahrenheit. Now if we focus in on our significant figures, we see that this was 2 sig figs, this is 2 sig figs, and so forth. So when we multiply these, we should only use 2 sig figs, so we'd use the 50, then plus the 32 with addition and subtraction. Remember that we focus on decimal digits of precision. Neither one of these would have any decimal digits, so our final answer is 82 degrees Fahrenheit. Okay, so we can use this equation to solve Fahrenheit to Celsius or Celsius to Fahrenheit. Use that one equation. And now to convert into Kelvin, Kelvin temperature, again just symbolized with the capital K, is equal to the Celsius temperature plus 273.15. Now, we may or may not use this 0.15 depending on our significant figures. So let's take this same 28 Celsius from our previous example. So 28 degrees Celsius plus 273.15. That will give us Kelvin. So that's going to give us 0.15, 1, 0, and 3. Okay, so 301.15 Kelvin. Now again, when we are working with significant figures and we're utilizing addition and subtraction, With addition and subtraction, we focus on digits of precision in the decimal position. 28 degrees Celsius has no decimal digits, so this should be rounded to just 301 Kelvin. Okay? So this is the formulas for converting Fahrenheit, Celsius into Kelvin, and Kelvin is the standard measurement of temperature in chemistry. Okay, so become familiar with the Kelvin to Celsius relationship.